Welcome to lesson 2.0 where we talk about Booleans and conditional execution. Woo! This is our first control structure that we're going to learn about in this class. You might have noticed I turned the camera to get a slightly different view. I need to plug into a power outlet that was over here, so that's why. Anyway, let's talk about Booleans and conditional execution, which is where we start to be able to make more creative programs, programs that have logic behind them. Yeah, logic. All right. So first, what is conditional execution? I'm going to give you some everyday examples, and then we'll look at how you program that kind of stuff into Java. So consider these situations. If I get all B's or higher, then I get to go to the winter ball because I love to dance. If I do all my homework, then I'll get good grades. What's another conditional? If the light is green, you're waiting at a stoplight, then I'll drive through the intersection. So all these things have in common is that the second statement, the part that comes after the then, is going to happen only if the condition is true. So, for example, maybe your parents made a restriction on you going to dances. Make sure that your grades are good. You can only go to the winter ball if you've got all B's or higher. Okay, so let's, these are just everyday examples. Let's look at what this looks like with Java code. So the if statement is what you're going to use in Java, just like we were writing if on the last slide a bunch. That's the same keyword Java uses, and most programming languages use if as well when you want to control code in this way. So this is the syntax. You write if parentheses and then a test, which is going to be some Boolean expression. We're going to talk more about Boolean expressions in a couple slides. And a Boolean expression is just something that's true or false. It's on or off. You can check about numbers. You can check about strings and so forth. There's lots of things that you can check for. We'll start off mostly with just number comparisons, but you're just deciding when you want to run the code. And then inside the curly braces of the if, you're going to write the code that you want to run when that test is true. And then you're going to continue having code afterwards if you want. Anything that's after this if curly brace is going to run after the test is done and after any code happens. So there's a little flow diagram that you should probably write down to describe this this if statement. So if coming down from the top, your code is running, you're chugging along, you hit a test. So we hit a test here, and at this we have a fork in the road. We decide, is the test true or is the test false? And if it's true, then you head down this way. So this is the true test. And you execute the code that's in the if statement. So you're going to execute the then code, right? If this is true, then do that. And when you're done, you head back, you leave the curly brace, and you hit the statements after the if, okay? So that will just keep going. And so that's the flow if the test is true. Now let's look at the flow if the test is false. So if the test is false, this is what would happen. You would hit the test. So this is a false test. Hit the test. You're false. You keep going, and you just go immediately to the code that's after the if statement. Okay. So that's if the test is false. And the previous one was if it's true. Okay. So that's the program flow for conditional. So what this is, what we're talking about here is called a control structure. So there's lots and lots of different control structures in Java. The if statement is the first of the ones that we're going to be looking at. Well, there's not lots and lots, but there's several control structures in Java, and we're going to be using all of them this year at some point. Control structures, as the name implies, control code execution. They determine when code is going to get executed, the code that's within their curly braces. So their curly braces are important. They're denoting what code you want to run if the control structure decides it wants to run it or not. Okay, so some control structures you may have heard of include the for loop, which is something we haven't talked about yet. We'll be getting to after we get through conditionals. If else, which is what we're talking about in this lesson, and the while loop, which will happen after we talk about if else, but still in this unit. So these are sample control structures that decide when code needs to run based off of some conditions. Okay, so let's talk a little bit about those Boolean expressions that I was mentioning earlier. So Boolean expressions are those statements that are true or false. So it's either true or false, and there's no in between. So for these examples, I want you to pretend that x and y are some integer variables. You know, they can be 5 and -2, or they can be 0 and 100, but they're just some integer variables, okay? So here's some Boolean expressions that you can use to put inside the parentheses of the test. So these are going to go where the test is. So these are going to be where test is inside the parentheses after you say if. So remember the line goes if, and then parentheses, and there's a test in here. So the test is a Boolean expression. Okay, so here's one example Boolean expression. We have x less than y. So what you think it is what it is. It's true whenever x is less than y. And it's going to be false when x is more than or equal to y. So for example, you know, if we had 5 here, if x was 5 and y was, so if y was 5 and x was 3, then that's true. And if x was 10 and y was 4, then x is not less than y, so it would be false. Okay? So it's either true or false, no in between. You can have less than or equal to. So the notation for that in Java is x, or syntax is x, and then angle bracket equals, so that's going to be less than or equal to. So that's true if it's less than or equal to. It's false when x is greater than y. X is greater than y, that switches the direction of the alligator mouth around. So when x is more than y, that's true, and when x is less than or equal to y, that's false. X is greater than or equal to y, that's going to be true when x is greater than or equal to y, and false when it's less than y. Okay, x equals y is a tricky one because equals is has two symbols. There's two equals right there, and because remember, a single equals means assignment. So note 2 equals. This is very easy to mess up initially, and it just takes some getting used to. That the double equals is how you compare for equality two numbers, and the single equals is how you assign a variable to, or assign a value to a variable. So yeah, make sure you're not accidentally assigning when you want to be checking for two things to be equal to each other. So it's true when they're equal and false when they're not. And then the exclamation mark symbol means not equal to. So x not equal to, x exclamation mark equals means not equal to. And so that's true if they're not the same number, and it's false if they are the same number. Okay, so that's a bunch of Boolean expressions you can throw in to test and control when code will run, depending on those values. Another thing you can plug into that test is a Boolean variable. So a Boolean variable is a variable whose value is either true or false. So any Boolean expression can be saved into a Boolean variable. So just like any string expression, any string literal can get saved into a string, and any number expression can be saved into a number, and so forth. Boolean expressions are, or Boolean variables are there to save Boolean expressions or Boolean values. So Boolean game over equals false. This is often used to have a game run until you're like, oh, the game is over, so I turn it to true and then I stop the game. So this could be a simple Boolean variable. Boolean greater than 5, that's equal to x greater than 5. So this is the, this is going to take whatever x is, compare it to 5, and then assign true or false to greater than 5 as a result of the comparison. So, if x is greater than 5, so if x equals 6, then x greater than 5 is true, and so then greater than 5 would be true. And if x was less than 5, then greater than 5 would be false. Okay. One thing to be careful about with this kind of thing is that if you were to change x later, greater than 5 would be unaffected by this. It's not updating itself whenever x gets changed. It's just looking at x's value right then and there, deciding is it more than 5, and then setting greater than 5 to true or false depending on that. Equal to y, this one's a tricky one, and I wanted to show it to you because we've got both the assignment equals. So this is the assignment equals. I'm going to use some colors to highlight them. So this one's assignment, and we have the double equals, which I'll use in red, the double equals, which means compare for equality. So the double equals checks if x and y are the same number, and then if they are, true gets stored into equal to y. And if they're not the same number, false is stored into equal to y. And so the assignment is the single equals, the double equals is checking if they are the same number. Boolean negative equals x less than 0. So, negative is going to be true if x is less than 0, and it's going to be false if it's 0 or more. So these are just example Boolean variables. So note all those on the left over here. Where'd my mouse go? On the left over here, these are all Boolean types. Okay, and a Boolean is going to be true or false. Okay. All right, let's do an example. So we're going to check if a number is positive. So if you want to check if a number is positive, you can have a simple if, parentheses, x greater than 0, if my number is x. And then inside, say I print out x is positive. So this is going to print the value of x followed by is positive only if x is greater than 0. So that println is only executed if this statement is true. Okay. Another thing you might check for is a number divisible by another number, right? Is 6 divisible by 3, for example? Yes. Is 10 divisible by 4? No, it's not. Okay, so if you want to check for divisibility, this would be the test you do. You use the modulus operator. If x mod n, n being the number I'm checking to be I'm checking to divide x, like x is my number, say 10, so say 10, x is 10, and n is 5, then 10 mod 5 is 0 because there's no remainder. Remember that mod is giving you the remainder after division. So this would print out 10 is divisible by 5, as you would expect. So mod takes the remainder, so n divides x if and only if that there's no remainder after division. Okay, so this is a common check you might make if you want to check if a number is divisible by another number. Okay, so here's a little thinker. How would you check if a number was even? When would a number be even? Even is a number that is a multiple of 2. So 2, 4, 6, 8, 0, -2, all of those are even numbers. What would you do to check if it was even? I'll let you think about that. Okay, so if-else structure. So the other thing you can do is you can have multiple things to do. It doesn't have to just be if this is true, then do that. You could have two options, right? An option A if the test is true, and option B if the test is false. So here's some examples. If it's sunny, then I'll want to wear shorts. Otherwise, I don't like shorts, so I'll wear pants. All right? So this is an A or B kind of situation. Depending on the weather, depending on if it's sunny or not, I'm either going to wear shorts or I'm going to wear pants. And I'm never going to go with both shorts and pants at the same time. So if I didn't have this if-else structure and I just had an if it's sunny, I'll wear shorts, and then I'll wear pants, I'd be wearing shorts and pants when it's sunny. But in this case, I'm not wearing both, I'm wearing one or the other. Okay? Only one of these is going to run. So the syntax is very similar to what we had for the if, except now we have an else that immediately follows that if. So if parentheses test, then you put the code for if the test is true, and then else, and then you put the code for when the test is false. And keep these curly braces together the way that I've got them, and it becomes a lot easier to keep track of what's within the if and what's within the else. Okay, so this is I've kind of set it up for, this is the test here, sunny. When it's sunny, then I'm gonna wear shorts. Let's do blue for that. So this is the shorts, and else. So that's when the test is false. So otherwise, the test is false, then I'm going to wear pants. Boom. So, okay. So that's kind of where things are matching up. And let's look at the flow for that. So what you can see is we have two paths and not this path and then a skip path. So it's either you take the true path, which is this way and down, or you take the false path, which is this way and down. And then you meet up and you keep running code after the if-else block is done. So you're gonna do one or the other, not both, and it just depends on the test. One test happens, check, true, do the true stuff, false, do the false stuff. All right, let's look at another example with our positive. So if x is greater than 0, we print out x is positive. Else, we print out x is not positive. Very simple. All right, so if x was initialized to 0, the statement inside the else block would run because x greater than 0 is false. So this would be your output. 0 is not positive in that case. Okay, all right. So you can kind of get the feel for this. Like, what if we have lots and lots of tests to make? Well, you can just wrap them all up into this long if-else, if-else, if structure. And what that looks like is you have a test for the first, you have your first test at the top, and the code for that if it's true. And then you would say else if a second test, the code for if that test is true. And one thing to note is that you're not going to get to the second check unless the first test failed. So that's why the code for test 1 has to be false. Or test 1 has to be false and test 2 has to be true here. Else if you have another test and then both the first two tests failed and the third one passed is when you're going to run that code, etc., etc., etc. You can have as many of these tests as you want. And then lastly, wrap it up with an else that checks for when all the other tests at the top, all the previous tests have failed, then you're going to run the code for all of those being false. Okay? So you can have as many tests as you want to go through, and it just processes them sequentially. So it checks test 1, then test 2, then test 3, then test 4, and so forth in that order. Okay? All right. So that means if test 2 was true, then it's never going to get to the code past there, right? Okay. All right, so let's look at an example where we do this kind of logic. So let's write a program that asks the user for their yearly income and then prints out their tax rate according to this table. So you can see based off their yearly income over on the right, so based off of this yearly income, they have an associated tax rate, and we want to print that tax rate for each person. All right, I've got an IntelliJ program set up for this. So there's all our tax rates. I've got my input set up in main, and I get their input, store it into an int, and then call the tax printer method that takes an income from the as a parameter. So let's go ahead and write this structure. We can either start from the top or from the bottom. Let's start from the top. If the income that they give us is less than 9325, then actually it's less than or equal to. Then equal to. Then we're going to print out what was your tax rate. Let's say your tax rate is 10% is their tax rate. Okay, and now we're going to make our next check. Else if income is, well, at this point we know that their income has to be greater than 9325 because the first test would have failed if we're going to make this check. So at this point we know it's more than 9325, so we just need to make a check that it's smaller than or equal to 37950, which is the next upper bound of the tax rate. So I'll just comment here, we know you can assume that income is more than 9325 here, okay? Because we would have failed the first test. Okay, so we'll print out your tax rate is followed by 15%. And then we'll run another, we'll have another else if. Since we're doing this several times, I'll just copy and paste, copy and paste, copy and paste, copy and paste. Let's see, what do we have? So the next one is 91900, and their tax rate is 25%. The next upper bound is 191650, and then the tax rate is 33%. And then we're getting into big bucks here, 416700, and then 35%. And then more, so now we're at the last one. So the last one is going to be true. We want this to be our catch-all, which is everything that's above, oh wait, no, we have one more tax rate to do, don't we? Wait, do we have them all? Let's see. We have less than 37950, less than 91900, less, oh, I missed a 28%. That's this one right here, 28%. And then this one's 33%, and then this one is 418400, and that's the closest to the highest tax rate. And now we're getting into you know, celebrity money, the Donald Trump money or whatever, up here, and that's the last case, which is why it's in an else. So we can see this program flow. The logic is we start at the top. If their income is smaller than 99,325, we print the first one. If it's more than that and less than 37950, then we print the next one. Okay, so in each of these you can assume the previous tests have failed. Okay, so I'll just assume that tests 1 and 2 failed. And so this one you'd assume that tests 1, 2, and 3 failed. 1, 2, and 3 failed, etc., etc. Okay, I'm not going to write them all, etc. Okay, all right, so that's our program for a tax printer, and we can run it. We can see how it works, if it works as intended. So our yearly income, let's try 30,000. So if we were to put 30,000, tax rate is 15%. and that's what we expect it to be. Okay. We're going to do one last thing with this. We're going to refactor it. And refactoring, remember, is when you rewrite code to eliminate some redundancy or to make it a little cleaner, more elegant. Remember the song Mini Lab where we did lots of refactoring over and over again? We're going to refactor that tax bracket so that it's a little simpler and it doesn't have so many gross println statements in it. And so I'll show you how we can do that. So what's common here is that we're saying your tax rate is every single time. So rather than continue to print this over and over and over again, let's try to figure out what is really unique about each of these. And the thing that's unique is that number right there, 10, 15, 25, 28, 33, 35, 39.6. So instead of having a println for each of these, let's just figure out that number. So we're going to get an double because the last one's 39.6. We'll call it the rate, and then we're going to set the rate to the value that we want it to be right here. And then we just print out at the end your tax rate is followed by the value of rate. So there's rate in there. Okay? And so now we're going to just go through and read and change each of these lines so that it's just changing the variable's value rate. Note it's not happy right now. It says it might not have been initialized yet. That's because we haven't given it a value for all of these different paths. So let's go ahead and do that. Rate equals 15%. Rate equals 25%. This last one's 28. This is 33. This one is 35. Oops. 35, and then the last one's 39.6. 9.6. So now you note that rate, we can use this. So we've just refactored it so it's a little more elegant. We have just one println. Makes it easier to read what's happening. We figure out what this rate variable is by this if-else logic, and then we print out the answer at the end. So it's a lot easier to read. So it won't have changed our code except maybe a little bit of formatting. So if we type in the same yearly income, 30,000, it says your tax rate's 15.0%. So, and we'll want to be doing this a lot when we write conditional programs with conditional logic, is double check, could we have made it more elegant somehow? Could we refactor it so that the code is easier to read and is simpler? Okay, so anyway, that's our first foray into conditional programming. Yay!